BlockCHANCE Online Live is an online live-streamed broadcast talk show about blockchain, AI, and green technology. We bring inspiring speakers and innovative thought leaders together to talk about current and future developments within these exciting new fields. Join us to learn how we can use these disruptive technologies to better aid humanity and strive for a fair, secure, humane, and positive future. Get involved in our community and share your opinions and ideas. Together, we can make a difference.
Greetings to you all good people out there and welcome to BlockCHANCE Online Live. My name is Albert Pezzi and today we will discuss about Polkadot. We'll talk about parachains, parathreads, substrate, and if this all sounds like alien words to you, don't worry, we will try to explain as good as we can. For all the people that are not familiar with Polkadot yet, let me give you a high-level overview. So Polkadot itself describes itself as a next-generation blockchain protocol that unites an entire network of purpose-built blockchains and allows them to operate seamlessly together at scale. If we look at the history of the blockchain, we see the very first Bitcoin blockchain could be described as a single-purpose blockchain. It runs only one program called Bitcoin. Then we have Ethereum that actually adds the opportunity or capability to blockchain to write your own custom programs with their own custom logic. But the problem with this is, beyond a bunch of other problems like scalability and so on, that it's only single-threaded, so it can only run one program at any time. Then we have Polkadot, which is actually sharded and can run programs in parallel. And in addition to that, you can even build your own custom runtime. So you basically build your own computer. And this is basically the differences between these blockchains from a very high-level overview. The Polkadot blockchain was just launched a year ago with the creation of the first block, the Genesis block, exactly 1 year ago, to be precisely. And since then, 4 phases have been completed. So Polkadot has transitioned to a complete decentralized and permissionless network. And last week, the 5th phase was launched, and this is also the final phase. This final phase will launch the Parachain functionality, first on Kusama, one of the test networks of Polkadot, and then soon also on Polkadot itself. There are a bunch of questions that I'm interested in talking about today. For example, what does this launch actually mean for the Web3 ecosystem? And how does Polkadot compete then to other solutions that are offering or promising a similar scalability as Polkadot does, like, for example, Cardano and Cosmos? And also, where there's a misconception that many people think Ethereum 2 and Polkadot are competing. But if we look at videos and interviews from Gavin Wood, one of the co-founders of Polkadot, they actually say, no, there is no direct competition at least, but rather Polkadot should be considered an enhancement. And I'm delighted to discuss these questions with Joe Petrowski. He is the technical integration lead at Web3 Foundation. And you're all welcome to join us and discuss and ask also very technical questions. We will try to answer them as easy as possible. Please say hello to the audience, Joe.
Hey, thanks for having me, Albert.
All right, fantastic. And I would like not to build any artificial tension and ask you boring questions first, but let's straightly jump into Polkadot. What is actually a damn parathread? Why do we need them? So, and what does this launch mean that you just had last week?
Yeah, so you mean the parachains, not the parathreads?
Parachains, yes, sorry.
Yeah, so a parachain is just kind of like another blockchain. So you could think of it as being similar to Ethereum or Bitcoin or any kind of other protocol that we would call layer 1. So when we think about Polkadot, we actually consider it more of like a meta protocol. So it doesn't actually, like the Polkadot protocol doesn't really describe any logic itself. It hosts other logic. So it just describes an execution format called WebAssembly. That's like an industry standard that's been led by Google, Mozilla, Apple, and all these like big tech leaders over the last 20 years. And has this like very stable protocol for just executing abstract code. And the Polkadot network actually just can execute these blockchains called parachains that compile down to this. And the advantage of being a parachain is that you benefit from the security of the entire Polkadot network and also native trustless interoperability with other blockchains in the network, which I think are all things that we could kind of dive deep on. But the short answer to the question is a parachain is just a blockchain, and you would need it because, like you kind of mentioned in the introduction, if you're building something on Ethereum, you're kind of sharing it with everybody else. So it has this gas metering in order to kind of like limit who gets to execute what and when. And that's great for letting people deploy untrusted code and have this permissionless deployment on top of the blockchain. But metering is really something that you would do if, well, it's untrusted. So if you don't know how long something is going to take, you might want to meter it. But for some of the more simple operations, say like an ERC20 token transfer, something like this has happened a million times, probably much more than that. So why would you need to meter it? So, this kind of like adds a lot of like bloat and overhead to applications. So if you are developing a heavy use application and you have a lot of functionality that has like, say, constant time type of complexity, and that can be executed, you can kind of like understand the bounds of it. You're not worried about some like infinitely long list being in this program. It's much more efficient to actually just code this directly into the blockchain itself rather than deploying it as a smart contract that gets metered every time.
Thank you for this very excellent explanation. And just to paraphrase and make sure that I understood correctly, so I can, and everybody in case, can actually build their custom solution, and then they can use the Polkadot network, or in particular the relay chain, as you call it, to actually secure their own blockchain, or their own parachain, as you name it. But how do I actually build such a parachain? Do I have to create my complete custom code, or is there something? I mean, yes, I can already name, like, there's substrate that you can use. And so how long does it actually take to develop such a blockchain, such a custom blockchain? Because I would argue, or people would argue, you need a lot of knowledge to actually build something that is super secure. How do you ensure this kind of security?
Yeah, so that's actually a really good question. So I guess even Polkadot kind of came before the substrate thing, actually. So Polkadot came from this thesis that there were going to be lots of blockchains in the world. So if you just kind of back up to before Polkadot and substrate even existed, we saw a lot of applications on Ethereum get kind of like stuck there. So just as an example, like the CryptoKitties team had this application in 2017, and then they just had to move off Ethereum and do their own. And we saw other things, even like within Parity, like we had to do like the UN World Food Program, but it was on like a fork of Ethereum implemented in smart contracts. We saw a lot of like enterprises doing like their own like Ethereum chain with smart contracts on top of it, and then we saw like other teams doing these custom chains. So I guess like the CryptoKitties one doing this like NFT chain. And so this kind of makes sense. So if you're going to have a world with lots of blockchains, that was kind of a trend we were seeing. And you can abstractly think of a blockchain as a single computer. So if this kind of predates like blockchain at all, is that if you look at kind of like the 1970s computer science literature on what is consensus and these like old algorithms like Paxos and stuff, it's like the whole goal of having a consensus system is how do you make a network of computers, like on an airplane, it might be like 5 flight computers or something that provide some redundancy or something. And in blockchain, it might be 10,000 nodes or something. But the whole idea is like, how do you make a network of individual computers appear to an end user as just a single computer? So if you ask this computer, what's the value of this storage item in the database, it shouldn't really matter. You shouldn't be able to tell as an end user if you're querying different computers in a network or if you're just querying a single computer. So this network of computers should appear as a single computer. And so if you kind of like accept that abstraction and say, well, if we have like these things called computers, they're useful. And then, like we kind of graduated to this concept of the internet where we said, hey, we have all these like individual computers that companies use and eventually people, we should connect them all together and make a network of them. You can apply the same kind of logic, like that blockchain is going to follow a similar trend. People are going to have their own blockchains customized for their own applications, but they're going to want to like connect them together. And this helps a lot just for like from an engineering point of view, you can let things specialize more rather than having this like generalization, which has a pretty big attack vector. In just that it's like very low level and complex to use. So we've seen this with like Solidity bugs and whatnot. So we started building Polkadot, and actually, like, I don't know, maybe like 4 to 6 months later, we actually like forked this off and started building Substrate because we realized that like there's all these different parts to a blockchain there, and most of it is actually not the thing that like makes the blockchain the blockchain. So we have all these blockchains like Bitcoin, Ethereum, Zcash, and whatnot. And if you think about like what makes those unique from like a user or application developer point of view, it's really this concept of a state transition function. So these blockchains store different information in a database, and then they have different rules for like what you can do with it. So as like a really simple example, like Bitcoin, it'll store like some coin ID and then an address that goes along with it. So it'll say like this coin or like this address is the one who controls this coin. And if you invoke some function like send, then it's going to like call into this function with some kind of logic about like, does the signature correspond to the address to which this coin is assigned? And so this would be like the state transition rules. And so when you just think about like a blockchain in general, you have this database and then you have a block with a bunch of requested state transitions. All of the nodes should execute those state transitions and then give you a new database with all of the updates. And so that's like the kind of like the tip of the iceberg that everybody sees, and that's what makes like like a transaction in Bitcoin different than a transaction in Zcash. Is they're going to have like different rules about how you can actually like spend one of these tokens. But there's all this other stuff that goes into like developing a blockchain network. So you need like peer-to-peer networking to connect all the nodes. You need an actual database. You need an RPC client. You need telemetry and monitoring and all this other stuff that goes along with engineering these like large global systems. And so there was like a lot of redundancy. And at Parity, like we had built clients for Bitcoin, Ethereum, Zcash, and we're working on Polkadot. And we're kind of like, well, hey, like 90% of the work we're doing is kind of the same. And the thing that kind of like makes Polkadot or like some other blockchain special is actually just this like state transition rule, which we call the runtime. And so the whole idea with Substrate is that actually like we provide all the lower level stuff, like the database, the RPC, the WebAssembly executor, which is kind of ends up being like the most important bit, which we can dive into a little bit as to why that is. And then what the like the blockchain developer actually does is they only develop the state transition function part. So they just say like, here are the storage items that I want to have in my blockchain. And here are the rules that I want. Like here are the functions that I want people to be allowed to call to modify those items in storage. And so this actually like really cuts down on development time by, several years really. As an example, like the first Parachain that we're launching, it's called Statement, and on Kusama it's called State Mine. And I've been like involved in kind of like moving along the development of that blockchain. And I think we started it in like March or something, and we're about ready to deploy. So, and a lot of that time was kind of spent like working out the final kinks of like how we actually make it interact with the relay chain. So it's not the most advanced blockchain in the world. It's pretty simple. But we were able to develop this and have it basically ready to deploy in under 2 months. Whereas, to develop like a full-fledged blockchain network from scratch, we've seen teams who started developing their blockchains in 2016 or 2017, and they're just launching them now. So this framework like really cuts down on development time and lets people focus on, not doing like the database and kind of all the other stuff that comes along with developing blockchains, but rather just focus on like the thing that makes their blockchain special, like what makes this an identity chain or an NFT chain or data storage chain or kind of like whatever you want to do with it.
Okay, let's say I use Substrate and now I created my own custom blockchain. How would I get connected to Polkadot? And especially like, since I'm a developer who likes tests, I would maybe try to connect to another network first. Maybe we can also spend a little time talking about Kusama, because somebody asked what this network is and why it has, for example, its own token. So can't we just have like, I think it's called Rococo, right? So the other test network that you have in place. So why do we have like another network, first of all, called Kusama? And also, how is the path for someone who created a custom blockchain? Do I need to ask someone, or can I just permissionlessly connect to Polkadot and Kusama?
Yeah, so connecting to Polkadot and Kusama, it's almost the exact same process, and it's permissionless. So it takes place in these on-chain auctions. And so I guess like there's a few questions in there, like why are there all these different networks, and then how do you actually connect to them? And I guess like the maybe like a pre-question to this is like, how does a substrate chain actually connect to Polkadot? And that is like through the WebAssembly interface. So what substrate does is actually just compiles, it compiles down all of your runtime logic into a WebAssembly blob that gets hosted on the blockchain itself. And so Polkadot can come to your blockchain, and the client actually has a WebAssembly execution environment inside of it. And so it can actually like pull in your runtime logic and look at one of your blocks and actually validate that this block passes. So you don't actually have to use Substrate to do this, because everything kind of compiles down to this WebAssembly interface. So as long as you can build a blockchain that compiles to WebAssembly, then you can connect it to Polkadot and Kusama. So these other languages like Go and C++ that also target WebAssembly, you can use those as well. Definitely Substrate is the kind of like easiest way for now. But I know we did an experiment where we built a blockchain in assembly script, and we're able to connect it to a test network. So I think like the tooling will develop a lot as well for people to use kind of like other languages if they want. And then so like, why are there multiple networks here? So yeah, we have like Rococo, West End, Kusama, and Polkadot. So we've kind of seen with like testnets on Ethereum that they're not really a great simulation of actual behavior on the network. Like there's really nothing at stake on them. And so there might be like, the people who run them are kind of doing so like, out of the goodness of their hearts, because they care about it and they want to like test on it. And you don't really actually get to test things in like real economic or adversarial conditions on these testnets. So we deployed Kusama actually like in like August of 2019. And we actually we had to restart it a few times. There's some hiccups at the start, but that's kind of what it was for, and learning. And unlike other testnets where you would just throw out like, anybody who wants tokens to play around with, we actually did like the same Genesis allocation as like the dot token holders, and just let the network kind of go from there. And so if you look at like the actual like test nets like West End and Rococo that are run by Parity, those like, West End I think has like 4 validators, or maybe 10 validators or something, that are all run internally, and it's kind of like a place where we can do some like really quick test deployments, and if we need to like stop and reset something, it's pretty easy to do, but it's not like a real test to like how things behave in the wild. And so that's where Kusama is really useful. So not only is it adversarial because it's a real network with like a real like token distribution. It has like actual community validators on it and stuff. So there's like 900 validators running on Kusama, and that gives us a few advantages. Like one is we can roll out things to Kusama before they hit Polkadot, and so we actually saw like we can get into this like shell parachain that's running on Kusama. We had this thing running like really smoothly on West End, and then we moved it over to Kusama and deployed it there, and it's been taking like it's having like a really inconsistent block time. So we'd expect like a block every 12 seconds, and it's been more like every like 1 to 4 minutes. So that's not something you can really test on like a test net that's just kind of run like by benevolent participants who are just kind of like chipping in. That's something that you only discover when you go out onto a network that's kind of run on like 900 validators with people using like all sorts of different infrastructure, whether it's like cloud or bare metal or like home laptops. Or I know like some people are running like validators on Raspberry Pis and whatnot. So that's something you only discover by like putting something out in the wild. And then also like we can do all this like scaling testing and like migration testing and everything. So like if people are kind of like vaguely familiar with BFT algorithms, the complexity tends to scale with the number of nodes or number of participants squared. So like usually you have the like rounds where people have to send a message to everybody they're connected to, and then kind of like keep forwarding these. And so if you double the number of participants, then you increase the number of messages that are being sent by 4. So you bump into like scalability issues there a little bit faster. So like on Kusama, we're running with 900 validators. On Polkadot, we're running with 300. And so this just gives us a place where we kind of can guarantee that like if it works on Kusama, it's going to work on Polkadot. So occasionally we have hiccups on Kusama, But then by the time we get those sorted out, then we know that Polkadot is a much more conservative and safe environment, and basically like Polkadot should never really break. And so finally, the last part of your question is like, how do you actually connect one of these parachains? So that goes through this on-chain auction procedure. So we have this candle auction mechanism where it's kind of like this very old like English auction system where they would auction off ships in the shipyard, and they would just like let a candle burn, and like whenever the candle burned out, then the auction was over. So it would kind of like give people the incentive to give their fair bid, because like the two things we don't want is either auction sniping, where people just kind of like wait until the last minute and bid there, or just like having it be undervalued. So if somebody like thinks the slot is worth X, then they should actually like put in a bid for X and not like X over 2 or something. So the way this works on blockchain, it's kind of hard to have things like randomly end on a blockchain, because who actually gets to decide like what's random? And it gives a lot of power to somebody if like a block author can just decide like, well, I'm going to generate a random number and like end this thing now. You don't really have a way to guarantee that they didn't generate like a bunch of random numbers that would kind of benefit themselves. So what we do is like we have like a closing period. So on Kusama, the auctions are going to be 7 days, and then like the last 5 days are this closing period, and at the end of the closing period, so at the end of the 7 days, we actually generate a random number which chooses a retroactive closing date. So you don't actually know during the auction if it's open or closed, and so you could have a bid come in on like day 6, that's the winner. But you could actually find out that the close was on day 5, and somebody who had bid before that, even with a lower bid, would become the winner. So this gives people the incentive to bid their like fair value early. And the thing with like this bidding is it's only reserving the DOT or KSM tokens. It's not really like spending them or anything. So you win one of these slots for some period of time. So on Kusama, it's 48 weeks. On Polkadot, it's 96 weeks. So pretty close to like 1 year, 2 year. And at the end of that lease, you actually get all of your tokens back. So it's really just kind of like the opportunity cost of like not having access to these, but you're able to plug into the network and have a parachain slot there.
So just to summarize quickly, so as long as my blockchain compiles to WebAssembly and meets certain requirements, I can connect to it. So I don't even need to use Substrate. So this is not a requirement. It might save me a lot of time because you already put a lot of work into this. And in addition to that, you have a real test system, let's call it, the Kusama, that actually it's similar to when you play poker with your friends. So if there is no money at stake, then somebody goes all in at some point, and they don't care really if they lose or not. They just want to have some fun. And this, of course, introduced different kinds of behavior that you have if you really can lose something. And then the auction itself follows an English auction system that you're using right now. What is my question here is, of course, who are what kind of parachains are we expecting to bid on these slots? So what kind of applications or what kind of companies, who are actually the people behind these entities? If you could give us like an insight here.
Yeah, we have a ton of teams building in the ecosystem, which always like I kind of marvel at a little bit, because even like I mean like Parity is a startup, and we launched Polkadot last year, but kind of working on this thing since like 2017, and it's like it was a big it was a very ambitious project. Like we're just in the process of rolling out like the final stages of it now, and that's risky, like to kind of like go all in like that. And just for like for people who are actually like building in the ecosystem, I think that's like pretty impressive, because like they're in startups, and so they're doing something risky, but they're actually depending on like us delivering something which is also risky. So I'm like really I guess like I don't want to say surprised, but like really like happy to see like how much development is taking place in the Polkadot ecosystem. So we see all sorts of teams. I try not to name names just because like I don't want to like play favorites or anything. But so we see a lot of teams doing like quite a few smart contract teams. So there's actually like a few avenues that we see people going down here. So like one is like to have bridges to Ethereum. Another is to have like full EVM compatibility. So there's there's one part of that which is like the EVM interface of like so that you could deploy like Solidity contracts on top of that. But the other thing is like the actual RPC stuff. So like there's all these, like MetaMask connects to this like Web3 RPC. And so there's all this like tooling that goes along with like the Ethereum ecosystem. And so like you can actually implement like RPCs in your like RPC endpoints in the runtime of your chain. So we see some projects like implementing this like full RPC suite inside of their runtime so that like you could just natively connect to like Ethereum based tooling like MetaMask and whatnot. We also see like a few like privacy projects like doing like these trusted execution environment computing where no information actually gets stored on chain. It's all like kind of like processed in TEEs in like encrypted side chains, and then like only these like encrypted proofs are actually put on chain. Which is some like data storage, a few different identity projects. So like there's like some projects doing like unique proof of personhood, and as well as like what's it called, like the DID, like decentralized. No, it's not decentralized. Some DID. Some like ID projects. Yeah, what else is there? I mean, there's a ton. I actually don't like to even think about it as just being parachains because that gets a lot of attention about like the parachain teams, and for sure like they deserve it. But there's also so much more that goes into like a blockchain ecosystem than just a blockchain itself. So all this tooling like wallets, infrastructure deployments, full nodes, light clients, indexers, block explorers, all of this stuff is super important and is becoming even more important with multi-chain applications. So if you think about something like Etherscan, you can look at a contract execution on Ethereum and just see like here's all the state changes that took place when I executed this contract. But when you start thinking about like programming in a multi-chain environment, this gets a lot more complicated. So you could have like some application on one chain invoke a bunch of functions, and it could include like triggering some cross-chain messages that actually send function calls to other blockchains that have them do some other like state change on their chain. But it's not synchronous. So it's like not all contained in one transaction. Like it'd be, maybe you have like some state changes in block 10, and then those triggers sending off a message to some other chain, and those get executed in that chain's like block 11 or something. And so building the tools to actually put together like, oh, hey, I made this one transaction on this chain. How can I see all of the stuff that happened because of that one transaction? That's super important, and it's a really hard problem. So I actually think like there's like a huge stack of technology that goes from like the networking and like very abstract stuff, like like networking and databases and WebAssembly, up to like the parachains and like what parachain teams are building, and then also like the tooling and infrastructure that actually goes around like making these systems practical and usable.
And there are tons of developers out there who are currently, for example, building on Ethereum, and they're eagerly waiting for something like Polkadot to show up and finally start their work. There are also, of course, the developers from the Web2 space who want to transition to Web3 and see the opportunity there. And after a short break, we will actually talk about how the Web3 Foundation can help you achieve your goals through grants, for example, that you offer, and also who is actually building Polkadot, because there are different companies and entities involved in all of this, and community members. And then we also will finally compare Polkadot to, for example, Cardano and Cosmos, and see why we actually may need Polkadot, or how they differentiate from these other blockchains. And so we will be right back after a short video.
Where are we heading? Who owns your data? watching a new dawn. Blockchain technology. Artificial intelligence. Sustainability. Be a part of the evolution. Hamburg, Germany, 2021. BLOCKCHANCE, 2021.
So welcome back. We just spent the first half of the show talking about Kusama, Parachains, how you can build your own custom blockchain, how you connect to this network, how the actual auction system works, and we also had a first look into how the near future of Polkadot looks like, what kind of applications and custom blockchains will launch. And now someone, E. Frost from the community, asks here, when I look at the other projects with more hype and market cap, they appear to me more like rehashes of ETH and Bitcoin, whereas DOT seems like a real innovation. And also, in particular, for example, Cardano and Cosmos. So the real question here is, or the interesting question here is, of course, how does Polkadot differentiate from these projects, and what are they maybe doing that Polkadot might not be able to do? Is there anything that Polkadot might not be able to do that they are doing?
Yeah, so all of these projects, like, they're quite different, even though they kind of often get viewed in the same light. Like, so Cosmos, I don't really see as like doing something that similar. They started from like a similar thesis, which is that there's going to be a lot of blockchains in the world. And so they built this kind of solution to bridge them together, but they're all these like independently secured blockchains. And so, like, if you just kind of look at the very fundamental assumption of Polkadot is like you have these issues of like scalability, interoperability, and security. And so I think everyone kind of looked at like scalability and maybe took different approaches. So you see like Ethereum 2 went with like sharding and having like a bunch of chains run EVMs. Cardano is going with like more of like, a evolution on smart contract where it's like still in the smart contract paradigm, but it's like more efficient, and also having like these side chains that you can spin up. And then Cosmos said like, well, we're not really going to worry about security so much. Everybody can do their own security. We're just going to focus on like horizontal scaling of moving logic into separate blockchains and letting them send messages to each other. We kind of took the approach of like, I guess like a mix of all of them, but really that like you can't look at any of these one factors in isolation and say that it's a solution or ignore the others. So if you look at like interoperability, for example, you could think about like the idea of being able to send messages back and forth, and you could call that interoperability if you want to. But this really ties into like security. In the fact that like a message's meaning really depends on the context that you receive it in. So if you kind of take this like extreme example, like you get an email from somebody and it's like, I'm your long lost uncle and I have $2 million for you. Do you really believe that message? Versus like if you got like a message like from your bank or something. That's going to be like very different. So like the context that you receive a message in is really important. And so if you have like multiple consensus systems, then you end up having to trust that consensus system. So if you see like multiple chains being secured by different amounts of value or like different amounts of security, then you don't really have a reason to trust a chain that has less security than you do, because you could rightfully believe that it's going to be attacked, and that the message you receive could actually be like forked off and not end up in the canonical chain. So this is where Polkadot kind of like takes the ETH2 route and says like, well, actually, like all of these chains should be shards in the same system. So if chain A sends chain B a message, there should never be a case where like chain A gets reverted to before that message was sent and chain B has accepted that message. They should both be reverted to back before that message was sent. And that means that like there isn't really a concept of attacking a single parachain in Polkadot. Like you can't just attack one parachain; you have to roll the entire system back. And where we differ from like Cardano and Ethereum too, and like I mean, I guess like the sidechain thing on Cardano is a little bit different because it's not really getting like this like block by block security. And like where we differ from ETH2 is this like idea of this heterogeneous sharding, where like each parachain can be unique, whereas like in Ethereum 2, you have all these shards that are just running the EVM. And what's actually interesting is like with WebAssembly is that it kind of depends how you look at it. Like from the perspective of the relay chain, it just sees all of these parachains that have some WebAssembly compiled down to a function that's called execute block. Whereas from the user side, they see all these like completely different chains, like a smart contract chain or identity chain or whatever. And so yeah, I would say like that's the key difference, is that like with Polkadot, you actually get like the security that comes along with the interoperability. So you can actually trust messages from other chains in the system. And also these chains can be like kind of unique and custom. And I guess like the main kind of like the core thing that like makes this all possible is this idea of having a meta protocol. So if you look at like any other blockchain, whether it's Cardano, Ethereum, Cosmos, I think everyone that I know of, it actually has like, you have like the validator or like miner nodes, and they have the software in them that says like, this is what the blockchain is. Like when you receive a block, like you need to process it. And a Polkadot client really only has this WebAssembly execution environment inside of it. And we actually store all of the logic about the chain on the chain itself. So it just describes what a blockchain should be, and we can upgrade it. We can process other blockchains like Parachains. And so it's like fundamentally a different abstraction layer. So like we're really just focused on this like core consensus of like who gets to author blocks, and not even who gets to, like it's really like the actual runtime decides like who gets to participate in authoring blocks, but really like who gets to author a particular block, and then this like execution environment to actually process it within, and then everything else is actually handled by the blockchain. So we don't really see that in any other protocol.
And so you perfectly described like this from a technical view, that we have the relay chain, which just sees basically WebAssembly code that they can execute. So they execute the block function. And then we have the user perspective that you just named, and this is what they actually care about, the applications. They might not even see the different parachains, but they actually just see an application that is running on a parachain, but they don't really need to care in many use cases. And what's interesting as well is, of course, who is actually developing these systems. And I mean by who are the companies or entities behind this? Because, for example, for Cardano, it's mainly the Cardano Foundation that is working on this. So it's heavily centralized. How does this behave in the Polkadot ecosystem?
Yeah, so we have a ton of companies working on this. So I guess like Web3 Foundation is kind of the stewards for the last couple of years, and has run like a grants program and all this stuff, and has done some contracting in the ecosystem to actually build. And then like Parity Technologies is the company that's kind of like leading development on the Polkadot runtime and client and substrate. But there's also like other companies. So there's one building a C++ client. There's another one called ChainSafe building a client in Go that has actually successfully synced both Polkadot and Kusama, I think. So this is actually really interesting because it's built in Go. It doesn't have the Polkadot runtime, so it doesn't have anything about like parachains or balances or governance or anything that's actually there. It's just the actual like client part. So it has like the networking, database, the WASM executor, and like an RPC interface, and that's pretty much it. And it actually just like it can sync the Polkadot blockchain because the Polkadot blockchain stores itself what this executable code is, and so the client can actually just ask the blockchain, give me your code, and can actually sync the full chain. And then we have like a bunch of other teams working on like infrastructure. So there's been some teams like on Finality and one other that I'm not remembering the name, that has deployed like quite a lot of public infrastructure. And then there's like these other like block explorers. So like Polkastats, Polkascan, Subscan, like quite a lot of those. And then a lot of teams who are building with Substrate and like building these parachains in the ecosystem. So yeah, I mean, we can talk about like some of the funding mechanisms, like grants and like treasury and on-chain governance stuff, if that's the direction you want to go.
Yes, before we go there, I would just like to spend another minute on the clients to make sure I understand them correctly. Are there, for example, like in Ethereum 2, we have a bunch of different client implementations. So we have from the Lighthouse team, the Harmony team, Prism, and so on. And we've seen like a couple of weeks or months ago that there was a problem, I think, with the Golang implementation at Ethereum. That caused a bug, and quite a few nodes had to update, or I think it was even the parity or the Open Ethereum implementation. I'm not so sure, but anyways, so we've seen the problem that are introduced with only a single client network. And we also seen a bug actually in the Polkadot ecosystem a few days ago that was introduced. What's the roadmap here? So are you planning to introduce many or multiple clients, or how, and also how did you deal with this particular bug?
Yeah, so like first on kind of like the Ethereum thing, this is kind of inherently the problem of having the runtime actually coded into the clients themselves. So you can kind of imagine like, like ETH and Open Ethereum and all this stuff have like different, they're written in different languages. And so they all have to kind of like implement this Ethereum virtual machine. And there could be like some edge case where processing some function leads to a different result in one client versus the other, which would cause a fork in the network, which is a problem both with like probabilistic finality and proof of work, but also with just like having the runtime in the client itself. And so we actually don't really have this problem with multiple clients in Polkadot because the client doesn't actually have any of the code itself. It just has this environment for executing WebAssembly. It's like your browser almost. I mean, like, like Google Chrome has a WebAssembly execution environment. So like you can run programs in your browser without installing software on your computer. It works just like that. Actually, I think like as a little like side project, somebody actually built a Polkadot like light client that actually like synced the chain inside of a browser. So without installing anything on the computer. So like because Polkadot is like self-describing and it actually hosts its own logic, as long as you have something that can execute that logic, the logic is going to stay the same. There's no way that like two different clients are going to end up executing different logic. As long as it's coming from this like WebAssembly instruction that is stored on chain. So that brings us to Polkadot's like bug that happened this week. It's been a pretty wild, say like 2 days now since this happened. So I guess like if people have been following along for a while, there was an issue where there was a minimum balance that was usually like around like 200 or 300 DOT in order to stake. So we do this like really big election, which I think we could probably spend like a whole hour on like how this thing works. But we have this like optimization problem that will like reduce like a bunch of like token holder preferences over who they want to nominate. And so you have this map of like 20,000 nominators onto like 300 validators. And that's a lot of information to fit. So like the system was having to kind of like truncate this and cut off like a lot of people at the bottom. And so we did successfully fix that so that it kind of reduced the minimum required to stake down to just a single DOT, which is the minimum to have an account anyway. So that was great, but the result was no longer truncated, right? So now all of a sudden we're putting this on chain of like, hey, we have these like 20,000 nominators pointing at 300 validators, which is on one hand, it's great that 20,000 people are actively participating in the network. On the other hand, that takes up a lot of space in memory. And so when we actually allocate this, this gets a little bit technical here, but like the runtime actually tells the host, like it's operating inside this WebAssembly execution environment, and it tells the host, hey, allocate me some memory because I need to process this block or this transaction. And this allocation is quite conservative because like we want it to be able to run on just any hardware. So we don't want to like say that you have to have a 64-bit machine or that you have to have like a big server or something. We want to, well, if you have like an old laptop or Raspberry Pi, like you should be able to actually sync this chain. So it's pretty conservative in how much memory it actually allocates. And in this case, the size of the solution with so many nominators actually got so big that it ran out of memory, and it caused a lot of the validator nodes to not be able to process that block. And so we fell back to another solution to get around this, which is like, well, we have all this code that describes the runtime, and we can compile it down to WebAssembly and execute it inside of this this kind of like protected execution environment for WebAssembly. But we could also compile this code down to like a native binary format and just have it run like directly on your computer outside of this like WebAssembly sandbox. And here it's like requesting memory from the operating system. So it's not really like confined by this bubble where the runtime is telling it like only take this much memory. And so that would work as long as more than 2/3 of the validators were running hardware that could actually execute this in the using like the natively compiled code. And we actually ran into a second issue with the solution, which is that there was actually a change in the Rust compiler between when the runtime was compiled and when the actual like when the WASM runtime was compiled and when the native runtime was compiled. And so that led to some issues of actually like computing the correct result. So we were able to get it by like making sure that people were on like the correct version and using like the right compiler to actually target and get the result that would have matched the WebAssembly execution, which we need going forward because if people are going to sync this using WebAssembly in the future, they need to be able to use the WebAssembly version and make sure that that matches. So it's been, I guess I would say, an interesting bug. It kind of like really ran into some like edge cases of like WebAssembly and how we actually execute this. So yeah, but I think we actually have a solution that was rolled out, maybe even like an hour ago. So hot off the press, and like yeah, there's a new release out that should work even in WebAssembly that allocates enough memory and everything like that. So yeah, it's been an interesting development, but it's still very early. Like we haven't even launched Parachains, so it's a good time to learn this stuff and get it sorted out.
Yeah, I feel like this incident shows that it was a very clever decision to roll out Polkadot in phases and learn step by step what can actually go wrong, and also isolate each phase from the others so that we can preview them and test them rigorously before we move on to the next step.
Yeah.
Yeah,
it's kind of like the importance of like the upgradability and governance is that like it takes, I mean, for Bitcoin it's kind of like their I guess it's like that's kind of the point, is that like nobody can really change it, but in other protocols that want to be a bit more advanced, you need to be able to upgrade things. Like there isn't a single app on your phone that hasn't been upgraded in the last 6 months. Like everything gets upgraded in order to stay relevant. And so being able to like actually just change this code in chain and like on chain and actually like upgrade itself is a huge advantage, that we can actually like move through these phases without really demanding like, there's no like hard forks or anything like that. So it's interesting and a very practical, or I think necessary way of moving forward.
Yeah, no, I feel like also with this approach, we learned from the past with all the hard forks that you just named that we had, for example, in Ethereum and also especially in Bitcoin in the early days. And because, they want to try new things, but there was actually no on-chain governance that they could utilize to upgrade this. And so they always are depending on the miners downloading new software and then maybe deciding to switch to it. And this is very difficult to keep track of and to actually see what is happening there. And so I feel like this is a very strong feature actually of Polkadot. I had to get used to this first because it felt counterintuitive to have some upgradability built on chain, but with the governance model built around it, it feels like something that is quite advanced. If I have, for example, now, and I'm switching to more like the business side yet, if I have a cool idea and I want to build something on Polkadot right now, but the only thing that I'm missing is money and maybe the network, who would be actually the players that I would contact and get in touch with to build something?
Yeah, so there's a few options. So kind of at Web3, we have a grants program. I think we actually have two grants programs. One is kind of like for let's say open grants where you can just like apply on GitHub and be approved very quickly. And then for larger ones, there's a bit more of a process. And then we also have like these on-chain funding mechanisms. So that's something we do with both Polkadot and Kusama, is that a portion of inflation and transaction fees goes into this on-chain treasury. And there's an on-chain council, that actually manages this treasury. And so there's actually like quite a few treasury proposals. I think in the last year, Kusama approved 67 of them and Polkadot 47 of them. I only know those numbers because I just gave an update like 2 days ago at CoinDesk about this. So it's quite active as far as like getting funding from the on-chain treasury. So there's like a kind of informal process that you can go through. Like we have all these chat rooms, let's say like Polkadot direction and Kusama direction, where everybody's kind of active in there. And you can put together like kind of a case for what you're doing and the funding that you're asking for, and actually just apply, without going through any kind of like organization, just apply for funding from this treasury or treasuries. So Polkadot and Kusama each have their own, and they each have their own councils. So we've seen like kind of some similarity and some differences in what they're willing to fund. So Kusama is definitely more on like the, say, like cutting edge or like riskier projects, like maybe it's stuff that people consider a little bit more out there. And Polkadot's a bit more conservative, but yeah, a lot of different options for this.
You have a very good overview of the current ecosystem and the upcoming applications and companies and projects. One question that we are interested in blockchains is always, how do you envision the year 2029? So what kind of applications do you expect that are enabled through Polkadot? And how is also, for example, the Web3 Foundation, what kind of vision do you have that you want to drive towards?
Yeah, that's quite far in the future. I mean, I kind of have an idea of, I think, what will happen in the next, say, 2 years, and the technology that really needs to get rolled out to make this much more powerful and scalable. As far as a 2029, that is a big horizon. I always kind of think that like if this is successful at all, then I would be nobody could actually predict it right now. So it's kind of like this other technology, like mobile phones and stuff, where whatever people think it's going to be used for ends up being totally wrong, and somebody else comes in with this crazy idea, totally different perspective, and build something that you would have never expected on it. I guess like that's kind of my personal success metric, is that like if I just see something that is just like, wow, I've been involved in building this for many years, and like I never would have imagined that you could use it for this. That would be really cool for me. I think like in a more medium term, I will be really interested to see blockchain applications that don't use blockchain themselves. So we see a lot of applications now that have a smart contract, and when you use this application, you interact with this smart contract. And I would like to see isolated blockchains replacing a lot of Web2 services. So right now, like if you if you use like one of these like food delivery services, like in Germany, like Lieferando or something, it's going to be like log in with like email and password, and fill in all this like information about your identity, and then like pay with a credit card or something like this. And I think I would like to see applications where it's like, you log in with your digital identity that's kind of like backed by blockchain attestations. And then you have kind of like your information stored in maybe like a reveal scheme. So you don't have to like kind of put in your like address and phone number and like all of this like personal information. You can only kind of like reveal the information that they might need, and then pay with like some payments chain. And these chains might not even need to send like cross-chain messages to each other, just to have like some application that is not using like a smart contract itself directly. It's just replacing all of these Web2 services with different blockchain services. Because kind of going back to the beginning, if a blockchain is successful, it really looks like a single computer. So you could kind of imagine like replacing the sign in with Facebook button with sign in with this decentralized identifier button. And I think that would be really interesting to see.
And of course, you also have like a roadmap as Polkadot or Parity and Web3 Foundation. Are there any known risks that might impact the roadmap of Polkadot? Is there anything where you don't know exactly because you need a lot of research to be done first, so you can't really name a date?
Name a date for what?
For actually reaching that milestone.
I mean, I think it's not that far off from being like technically possible. If somebody really wanted to do it, it's not that far off. It's more about like the tooling and infrastructure to make it easy to do. So like right now, if you want to spin up like a Web2 app, you can just go to like AWS and like click a button and you have like a web server running, right? It needs to be that easy. People aren't going to jump through hoops to use something. I think we've seen enough where like Snowden revelations and all of this where like people still kind of choose the convenient path, and they're not going to jump through a bunch of hoops for something that's even just like 50% better. It needs to be 10 times better and also easier to use. So I think like that's just where we have to get, and that takes time. This is still a very young industry with a very long future ahead of it.
All right, thank you very much. We reached the end of our show. I want to thank you very much for these detailed explanations. This was very excellent. I think we got a very good introduction into Polkadot and also learned about the very next steps and how to get involved in this ecosystem. So if you have any questions or want to get in touch, use GitHub, go to the Web3 Foundation webpage, contact Joe. He's very approachable as well. And if you have missed anything or want to share this talk with any others, you can find the link on YouTube. You can also just follow us on Twitter and LinkedIn, and find the newest shows there. For next week, we have Vanessa Grillet. She is currently the head of portfolio growth at CoinFund. She was at Consensus before that, and we will talk about how decentralized finance leads us into a new financial system. I'm very excited about this. Thank you very much once more, Joe, and everybody have a good day, and long live the blockchain.
Yeah, thanks, Albert. Thanks, everyone.